termites. From the outside and from the inside. More than 2,000 species of them. Multitasking. Building. Harvesting. Transforming. Reproducing. Trapped. You'll see their enemies and their end. And you will penetrate to their secret center. In the East African savanna, termite hills are nothing special. Unless you've never seen inside before. Seen their sunless, secret lives. And the scale of their citadels. Eyeless, teeming insects. And yet it seems to know them is to love them. Especially when you understand the roles they play in the functioning of our planet. Studying termites can be frustrating. They're not the most cooperative of beasts. They do their own thing. But these two veteran scientists are about to share a profound insight. A glimpse into the termite's inner sanctum. A secret that has resisted all investigation. A comfortable retirement should have rewarded biologists Joanna Darlington and Reinhard Leutold. But when you're as dedicated to termites as they are, you can't retire while there's so much to learn.
One cannot never be absolutely sure.
Yes, you can be absolutely sure if they're building, but you can't be absolutely sure that they're dead if they're not building.
And if they are dead,
They disagree on details, but they know these ancient insects are key players in habitats across the world.
In this ecosystem, they are the main agents for the breakdown of dead vegetation. The soil is baked by the sun, and things like bacteria and fungi can't live near the surface at all.
Termites help this arid land bear fruit, but often there's no visible sign of them.
It's hard to study them because they don't like being exposed. So a lot of my work is reconstructive.
Termite research is like archaeology, excavating buried cities, drawing conclusions from the evidence of abandoned sites. Open up a termite mound and the termites disappear deep underground as though they'd never been there. But there's one group of termites that has nowhere to go because they can't move. And the challenge is to observe them without destroying their home. The inner sanctum. The Queen's Chamber.
Yes, so this is the Queen's cell.
The Queen. Huge, super productive, mother of every individual in a city numbering 1 million, together forming a single superorganism. Immediately, her attendants scurry to wall up the opening Joanna has made. The sudden changes in temperature, humidity, and brightness have sent them into a panic. But it's an orderly one. Her workers have plenty of water ready to produce instant cement, even in this dry place. Soldiers' powerful jaws guard the shrinking gap, ready to repel intruders. For a few seconds, the researchers have glimpsed the heart of a termite superorganism, or rather its womb, the very source of a colony's life. In many countries, termites are feared, hated, and hunted down. They can be a few centimeters away and you'd never know. Unless you call in the professionals.
A little bit more activity here. We got some drywood termite, some pellets right there.
To crawl under the house and squeeze into impossible corners.
There they are. We have to treat this beam here.
It's the same indoors.
We could probably E-gun it from
Cut that beam open and you're in for a shock.
roof. We could get the whole beam.
To these critters, your house isn't a home. It's an all-you-can-eat diner. They'll take everything they can get. What are termites? Some folks call them white ants. They couldn't be more wrong. Ants have been around as long as termites, and like termites, they're social insects. But unlike termites, many are carnivores. Other insects are frequently on the menu. Ants evolved from wasps. Termites, on the other hand, are descended from cockroaches. And they're strictly vegetarian. In fact, termites will eat everything from lichen to dead wood. That's one of the secrets of their success. They're a lot more than just pests. Let's take a trip via computer tomography through the gut of a drywood termite. It's built to process cellulose and lignin, the tough materials surrounding plant cells. The termite bites off small fragments of wood. First, these are softened, then they're shredded. And all that happens in just 1 millimeter. Let's go back inside. The fibers are squeezed on through the tract until they reach a special gut, a kind of a paunch, containing single-celled organisms called flagellates that break down cellulose. Flagellates make up 1/3 of a termite's body weight. Without these flagellates, termites would starve. They extract enormous amounts of energy from the cellulose and pass it on to the termite, leaving just a few tiny crumbs of feces that you may never even notice. A family like this can live happily in a house for years without any idea that termites are on the attack. Though the microscopic signs are there, and the sounds. Here in Kenya, termites are part of the landscape. People respect their monumental mounds. Farmers protect them, even when they're right in the middle of their fields. A tractor occasionally runs over a termite tunnel. The tunnels reach well beyond the visible part of a nest. This is a young adult, almost ready to leave the colony and found a new one. Termites try to stay underground. But to find a mate and a suitable site for a new colony, they have to emerge into the open air, usually at night. It's the riskiest moment of their lives. Farmers like the highly productive moist soil around the mounds. Whatever helps them grow food here is welcome. 8,500 kilometers away on the island of Borneo, the climate looks made for termites. The rainforest is constantly humid, warm, and well shaded. This is probably the sort of habitat where termites originated. These species have it made. No need to stay underground out of the heat or dig deep for water. For their nests, they have hollow tree trunks. Unlike their drywood termite cousins in America, these termites don't eat the timber they live in. So they have to launch food-gathering forays every 10 days. Scouts have identified a harvesting site and mapped out an ideal route through the congested landscape. A gland on the scouts' abdomens lays a pheromone track for the others to follow. Their dark chitin shell allows them some exposure to sunlight. This is where the harvesters go to work. A patch of lichen clinging to a tree, up to 100 meters from the nest. That's 15 kilometers on a human scale. These harvesters, young worker termites with their small, sharp jaws, won't eat anything out here. They'll scratch, graze, and gather all they can at a frantic pace because the entire army is operating to a schedule. In less than 30 minutes, this trunk is scraped clean. Time to hand over to the transporters. A division of labor established 100 million years ago. This one will wait until he has his full load. And then he's off. The harvesters and transportation workers suddenly know it's time to be getting back. Unless they get sidetracked. The crinkly white paste on the pitcher plant's rim is termite caviar, enough to distract them from an entire lichen tree. But the rim and the inside of the pitcher are super slippery. A single plant with several pitchers can fill up with thousands of termites that it slowly digests. The termites bring home half a kilo of raw plant material to feed 1 million termites for about 10 days. Perfect organization without any organizer. But being out in the open is risky, and the biggest risk is dehydration. That means sunny spots must be crossed as fast as possible. Gaps in the canopy are a problem. Logging is a disaster. Termites have softer exoskeletons than ants. Keep them in the sun too long, and they boil. When the sun comes out, they huddle in the shadows. or they put on a burst of speed to get home fast. These termites prefer to exit in the morning or afternoon when the sun is warming up or cooling down. Their thin skins also can't cope with cold, fog, and rain. The rain clouds pass, the march goes on. This expedition has gone well, with no predator attacks. The losses to the carnivorous plants will go unnoticed. Once back at base, the colony will stay underground for 10 days, processing the harvest, tending to the brood. Back in America, the war on termites continues. You can poison them, gas them, or zap them. But there's only one problem. However efficiently a building is cleansed, right next door in the backyard, a new generation of termites may be emerging, primed to reinvade. In this war, termites outnumber humans. In East Africa, the same is true, but here termites aren't seen as pests. This gigantic single-vent termite mound says it all. Termites dominate life here. On a human scale, this tower would be 1,700 meters high.
They have to build high in order to get the ventilation system to work efficiently. So basically, the denser and higher the trees, the taller the mounds get. But it's quite impressive, isn't it?
To see a colony building a new vent, Joe and Reinhard have to put in a night shift. This mound is still a construction site. They need a gentle light source to see the termites without disturbing them. An infrared camera will let Reinhard record the colony's activity. Tens of thousands of builders bring up clay and water from deep underground. In the short run, these termites are mining building materials. In the long run, the minerals they fetch from the deep enrich the topsoil. They mix the clay in their jaws with water they carry in their bodies. To find it, these termites may dig shafts all the way down to the groundwater, 60 meters or more below the surface. The work is hectic, but it's orderly, and it never stops. mound is living, eating, and breathing like one huge animal. The comparison with an animal is a good one. The breath of a termite colony is nearly as warm as a mammal's. It's also supersaturated with moisture, reflecting the internal climate of the nest. When a rare shower cools the air, you can see the vent steaming. By first light, this vent has grown by half a meter. It's not finished yet. Later, all the gaps will be filled. The termites regulate the flow of gases so the queen's chamber stays at 30 degrees centigrade and close to 100% humidity. This mound is alive and breathing. But not all mounds breathe in the same way, as Joe Darlington discovers.
Yeah, right on the far side. The difference is mostly in the ventilation systems. The different species have chosen to use different ways of ventilating the mound. This one's smoking very actively, and that one, and this one's coming up too. What counts here is the difference between the top holes and the bottom holes, because the wind is stronger the further above the ground you get, so that the high holes suck air into the low holes and it passes through the mound.
To live in this dry, hot climate, termites need air conditioning. But these vents don't just keep a termite mound cool. They also expel waste gases, carbon dioxide and methane. Mounds with a single vent are especially valuable to Joanna and Reinhard. They can use them to measure how much gas is released. And that helps them estimate the number of termites living in a single mound. You have to be careful when dismantling a heavy vent. This was built to last. Multiply the figures from one mound by the number of mounds in the savanna, and you could theoretically work out how much greenhouse gas, especially methane, Africa's termites release into the atmosphere. Get it right, and you know the contribution termites make to global warming. But it isn't an exact science yet.
We can't make any meaningful estimate of the biomass of termites. We have figures for which termites produce how much methane, but we just don't know how big their population, how big their biomass is. So yes, they are a contributor, but we don't know how big. It's easier with something like cattle. Now, cattle contribute in the same way. It's the intestines, in both cases, which produce methane as a metabolic waste product. But whereas with cows, it's relatively easy to count the heads and work out how many there are, and so how much methane they produce. With termites, we don't know. We know there are a lot, but we don't know what their biomass is. We need to know more about them.
Hacking into the base of the mound reveals the passages of the subterranean city. Stragglers from a termite nursery are the last to scurry to safety. Once again, entomologists become archaeologists as their live objects of interest disappear before their eyes. While Joe and Reinhard investigate their Kenya colony, another termite colony is receiving a lot less attention. It takes a child's sensitive ears to pick it up at all. What is that tapping sound?
You're welcome.
Want some more shoes?
Yes.
Here.
Some more.
Thank you.
I heard like this noise last night in the wall.
Really? What kind of noise was it?
I don't know, it's like a...
It's probably just a boogeyman. Sure you weren't dreaming?
Yeah, I'm sure.
Danny wasn't dreaming, but this is a nightmare.
Hi, Rose.
Finding someone as thorough as Rose these days is rare. But all she's doing here is clearing up the evidence. Drywood termites have an old saying, "My home is my dinner." No excursions to distant food sources, no exposure to hostile eyes. Working from home is so efficient, you can be truly relentless. So relentless, in fact, that termites cause more damage to homes across the world than hurricanes, fires, and floods combined. More than $20 billion a year. Here, the next generation is about to go forth and multiply. The sexual caste is already growing its wings. In a few days, thousands of them will emerge into the light, mate, fly away, and start new colonies. Over in the tropical zones, the biomass of termites, their total weight, is immense. And yet, to the casual visitor, they can be almost invisible in the forest floor's kaleidoscope of browns. This termite species have found a way to even out the vastly different surfaces they have to cross to reach a food source. Where the gaps or height differences between leaves and twigs become too great, they build roads, bridges, and tunnels. With sand and earth gathered from the forest floor. Another form of termite concrete. They use it to construct a direct route to the food, saving time and energy. It's a superhighway taking rush hour traffic through the most difficult and complex terrain. Pheromone trails regulate the traffic as smoothly as road signs and traffic lights. The tunnels are even designed with one lane in each direction. Soldiers line the entire route, facing outwards, sniffing for danger. These are a big-bodied caste, their heads converted into chemical guns. Their antennas scan the air. The forest is full of risk. Closer to home, the engineered roads and tunnels become still broader. Nothing impedes their forward march. Workers cutting up dried leaves to take to the nest. The detritus they leave behind rots away and helps new plant growth on the forest floor. Cutting up dried leaves is hard work. It takes 2 hours to make a leaf disappear. And this termite species eats only leaves. We're only just starting to understand the termites' role in the planet's ecosystems, but it looks as though they have a positive effect on the lives of almost all plants and animals. So instead of focusing on extermination, some researchers are beginning to think we should be protecting termites all over the world. Through 150 million years of evolution, termite species have learned to process any kind of vegetation, dead or alive, into food. That adaptability has been their great strength. And with their perfect social systems, termites should effortlessly dominate their environment. But here in the jungles of Borneo, there is a predator. Tucked up in the dry leaves, it looks like a snake. As it stretches out, you might mistake it for an armadillo. But the only thing it has in common with armadillos is that, like an armadillo, it's not a reptile. It's a mammal. This is a pangolin. The pangolin has long claws to break into termites' nests, where it uses its sticky tongue to lap up the insects wholesale. Today, the termites are lucky. An ant colony is paying the bill for the pangolin's dinner. But termites don't just face a threat from pangolins. These soldiers are scanning for a very different enemy that they can't see, but may soon sense. A platoon of weaver ants has targeted the termite column. Their scouts have chosen the perfect ambush site. An ant patrol inches toward the termite highway. The worker termites seem too busy to notice the danger. Some of the termite soldiers have picked up the hostile scent, but they may not leave their sentry posts. The ants spend time scouting out a gap in the termites' defense line. Finally, they opt for a head-on assault. The termites are not defenseless. The tiny termite gunner has aimed well. It tries to wipe off the acid spray in vain. Termite soldiers launch a counter-assault and engage the enemy in a skirmish. A few ants manage to retreat with pieces of termite booty in their jaws. But the tiny defenders have stood their ground thanks to their chemical weapons. Across the globe in the savannah, another ant army is on the move. This time, it'll be more than a skirmish. The advance is fast and focused, led by a single scout. They fan out from their nest in 3 parallel columns, each 2 meters long. These ants are like bloodhounds, hot on the scent. They exist to hunt termites. There's no escape. These savanna termites have no secret weapons. Outnumbered like this, their size and fearsome jaws are no advantage. The ants drag termite bodies back to their nest, retracing the lines of their advance. Biologist Jo Darlington has watched plenty of these campaigns from above. She never ceases to wonder at 2 insect types that can be so similar and yet so different.
Well, ants and termites between them are the most successful of all the land insects. We think they're the first social insects, but the fossil record is very incomplete. But although there are a lot of parallelisms, they're actually not related at all. They're an example of convergent evolution, where different stocks have solved the same problem in parallel ways.
Jo continues her work to calculate the biomass of the termites in the savannah. She maps out all the mounds in a defined area.
I feel the same, the edge.
Feel for the edge of the mound in this direction. Further out. Hold it up. Now GPS is ready.
2 termite species live side by side here. One builds mounds. The other lives completely underground. this species comes out at night. They spread out over the savanna, gathering vegetation, dragging far more than their own weight. The ground is dotted with tiny access holes, sealed by day, leading to the tunnels the termites have dug around their nest. They radiate up to 35 meters from the nest in a dense network. A single nest can have 6 kilometers of tunnels. Termites remove dead grass and woody litter, reducing the risk of catastrophic fires in the dry season. Back in the nest, the termites will eat this plant detritus. These termites are able to break down cellulose like their American cousins. Other species eject the chewed and moistened cellulose as raw feces, which will later be used to farm a fungus. That's what the termites in this mound do. These Maasai women have never looked inside a termite's mound before. But Reinhard has installed a window to observe a fungus garden. These termites are working on the fungus garden, or comb. Worker termites build up the structure over several weeks with layer on layer of feces. The fungus comb produces white spores called canidia. The workers swallow these spores and excrete them with more feces, further enriching the fungus. This is the main source of food for all the termites in the mound. Thus, the fungus guarantees the existence of an entire termite species. And it all depends on the temperature and the humidity being exactly right. For these Maasai women, a fascinating first glimpse of the insects that keep their lands fertile. For people in California and the southern USA, the only good termite is a dead termite, as desperate homeowners call in the termite terminators. Houses are fumigated from top to bottom with poison gas. Climate control in single buildings and whole cities has helped termites stray way beyond their original habitats right across America, Australia, and parts of Europe and Asia. Getting rid of them is big business. But not even this is enough to guarantee success. In Kenya, Joe and Reinhard are nearing their goal of reaching the Queen's Chamber, the inner sanctum.
What do you think about this one?
At last, they've found a suitable mound to work with.
It's been damaged a bit by the rain, but they sealed off the entrance.
There is a good shade here.
It's easy enough to remove the Queen's Chamber. But opening it up without destroying the colony is a very delicate task. It must be turned upside down.
Where is the soldier? Have you got this thing?
Yeah, it fell down. I don't, unless it's
Maybe
on
there is a... Yeah, there.
Joe and Reinhard have been waiting a long time for this moment.
Yes, there are.
But they must be very careful. If the soldiers get nervous,
I've seen the
they might attack the Queen.
very sure.
Well, she should be. She should
Yeah,
be,
that's okay.
lying in the hollow of the roof.
Yes,
So she
I
should
want
be
to
safe.
look down. There are the big soldiers going ready.
They probably, it probably will be all right. It's just sometimes they get a
But they
bit curly
do.
and damage the queen.
Yeah.
I will lift it off him.
Or we can do it this way.
This is the moment of truth.
Oh, 3 queens. There's a king.
Oh, the king.
Not one queen, but 3.
I've never seen queens before. So there's the other king.
The king, just 1 centimeter long, fertilizes the queen all her life, up to 30 years.
That's the one we have.
Where do you want to put them?
Now, well, we take the largest and put it in the queen cell.
Well,
You see, there are
I think, yeah.
Reinhard has brought a laboratory out to the savannah. He hopes that a queen, her king, their workers, and their brood will behave naturally in an artificial chamber. The tubes linking the chambers to the nest are coated with pheromone trails to encourage the workers to keep looking after their queen.
So at least there is no big soldier inside. That's most important.
The 2 remaining queens and their king are returned to the nest.
Make it as level as you can. Don't press it too hard because it's got live termites in. They have at least a chance of finding their way back.
For many years, researchers have tried similar setups, gradually refining the technique, but it's notoriously difficult to film natural termite behavior in a queen's chamber.
So now I put
There goes the king.
together with the queen.
The cell must be protected from the heat and light of the sun as quickly as possible.
Now these we have to select first. I cover it first. This is
Now the connecting tubes are linked to the natural chamber back in the mound. It's a tense moment. If the queen is stressed, the soldiers and workers will immediately kill her.
somewhere into the. Yeah. Okay. Put the stones again, please.
Now there will be a long wait. Will the queen and her workers return to their routine? Feeding, egg laying, and tending the brood? Even with all Joe's and Reinhard's experience, they still need luck on their side. The queen and the workers don't seem to be disturbed. The workers are still tending to her, and the queen keeps producing eggs, hundreds every hour. All eggs are born equal. Whether they turn into workers or soldiers depends on the food they're given. Sensitive to disturbance in the savannah, resistant to shifting in the suburbs, it pays to pay attention to termites. So wherever you live, take a good look at your home every now and then. And have a careful listen, too. It might spare you a big surprise.